Lesson 8.3 is all about vectors. You may have run across vectors in physics class. It's something that we haven't really talked about before in math. But we need vectors because some quantities, like force and velocity, have both a magnitude and direction. And so we can't represent those by a single number. So what we do is we use a directed line segment. So when we do vectors, we might have PQ, and it's hard to see it here, but there's actually a little arrow here on that end of it. That was terrible. It looks like a ray, okay, PQ. So P is the initial point, so there would be a dot here, and then Q is the terminal point, so there's an arrow there. That's a lot better. Okay, so it tells us what direction it's going, and the length of it tells us its magnitude. So magnitude is length, and we represent length like this. It looks like double absolute value. And we find length just using the distance formula. This should be super familiar to us. Two directed line segments, or two vectors, have the same, if they have the same magnitude and direction, we call them equivalent. So in number one, we want to show that U and V are both equivalent. So we need to show that they have the same magnitude and the same direction. So we'll start with vector U. We want to find the magnitude of U. And to do that, we're just going to use the distance formula. Notice that U starts at the point 0, 0. Sorry about that. Little stray line there. And it ends at the point 2, 2. Oh, not 220. All right, so we are going to find the magnitude of this. So using the distance formula, we're just going to do x minus x, so 2 minus 0 squared, plus y minus y, 2 minus 0 squared. So that's going to give us 4 plus 4, which is the square root of 8. As you can see, I am not very good with this handwriting thing here. All right, we also want to know the direction of U. We're going to talk about the direction of U just by using the slope. So slope is y minus y over x minus x, and you can see that the slope of U is 1. We'll call that slope U. All right, we also want to find the magnitude of V. So V starts at the point 1, 3 and ends at the point 5, 5, 3. Nope. Oh, sorry. That was not right at all. How about 3, 1 and 5, 3? That looks better. Okay. So using the distance formula, we're going to do our x minus x squared plus y minus y. And that's going to give us, let's see, 4 plus 4, which is also the square root of 8. So those have the same magnitude. And now we want to find the slope of V, which is going to be y minus y over x minus x, which is also 1. So we have shown that vectors U and V are equivalent. Just a little note, your book is going to use bold letters when it's talking about vectors. That's hard for us to write when we're like taking notes and stuff, but just so you, when you see it in your book, bold letters generally mean vectors. Okay, so a vector is in standard position if its initial point is 0, 0. So you can see the vector U is in standard position because it starts at 0, 0 and then it goes out. Vector V is not in standard position. Okay. Any vector, no matter where it is, it can be written in component form. Component form, instead of using coordinates like XY coordinates, it used brackets. And this tells us where it's going in the X direction, and this tells us where it's going in the Y direction. Now, if you have this, you need to know its starting point in order to be able to use this. But if you assume this in standard point, this tells you X, Y, where it's going in the X direction and then the Y direction. Component form is something that we need to know as a vocabulary term. All right. Now, Any vector, no matter where it is, it will have an initial point and a terminal point. So in this case, we've got P and Q. And if we want to put this into our component form, we do terminal point minus initial point for the x's, and terminal point minus initial point for the y value. Okay. And then the magnitude, again, is just the distance formula. Now, if you have it written in component form, if it's already written like this, we can kind of shortcut distance formula, because this V1, we've already taken x minus x and y minus y. So we can kind of skip that step, and it's just kind of shortcut distance formula. Let me show you what that means. It's easier to explain this in the context of a problem. So first we want to find the component form for this vector. So it starts at -2, 3, and it ends at -7, 9. So to find the component form, and remember that's the thing with the brackets, we have to take terminal x, so this is terminal x, -7, minus initial x, -2. Now we haven't done the y yet. We'll get to that. So -7 minus -2, that's plus plus, so -5. And then for the y coordinate, we're going to do terminal y minus initial y, like this. Okay, so what this is telling us is from our initial point, it's gone left 5 and up 6. Let me actually graph that for you. So if we started at -2, 3, and we ended at -7, 9, which isn't going to fit. Okay, that's our vector. Wow, that was not a straight line. This vector has gone left 5 and up 6. So from here, we've gone left 5 and up 6. Okay, so this is component form. Now, if we want to find the magnitude, I'm just going to call the vector, this is supposed to be vector v anyway. So if we want to find the magnitude of vector v, we could use the distance formula on these 2 points, just like we did before, or we could just use this, because we've already done, this is already x minus x and y minus y. So we can just say, we'll take that, x minus x, and square it, and the y minus y and square it. And so we get 25 plus 36, which is, I don't know, that's the square of 66. Let's hope so. Okay, so that is kind of a shortcut for finding the magnitude of this. We'll talk more about vectors in the next video.